All right, so today we have Shreya Shankar, PhD student at UC Berkeley in the EECS department. So, Shreya, welcome to the podcast.
Thanks, Ben, for having me.
You've done a lot of really interesting work of late. I think one of the themes seems to be data processing, but a specific kind of data processing. Before we go into what tools you built and what solutions, what specific approaches you are using, let's start with the overall problem you are trying to address. What specific problems that you think that regular enterprises have where you saw a gap?
Yeah. So for decades, enterprises, not just enterprise organizations in general, have been struggling to make sense of unstructured data. And when I say unstructured data, I think like long text documents or PDFs, even images, videos. But there's just a massive amount of text that people wanted to make sense of automatically. And we never had the technology to really do that until large language models came around. So I was at this great time in my PhD where, I just completed some of my preliminary requirements for being a databases PhD, and I kind of understood how data systems work to some extent and how we built primitives for being able to manipulate data. So I spent the last couple of years building a processing framework for people to manipulate their unstructured data with large language models. So specifically, how can we extract semantic data from them, aggregate them? And turns out that this is a really, really hard problem, which I'm excited to talk more about.
I guess the prior art here, Shreya, would be using NLP libraries, right?
It would be, yeah,
And then just doing kind of really bespoke, I don't know, whatever task you're trying to do, entity extraction, entity
yeah,
resolution, everything bespoke.
yeah. There are two flavors of approaches we saw here. One is exactly what you're saying, these bespoke pipelines that leverage, or people would train their own models to do tasks. Or crowdsourcing based approaches is actually quite popular in the 2010s, late 2000s. People would write crowdsource data processing pipelines. People still do this to label their data, and then they try to train models on it. But now LLMs are kind of able to make it much more simplify the process in both areas.
So the typical task then, as I understand what you're saying, is I have a large collection of unstructured text and I want to extract as much structure out of them as possible. So by structure, I don't know what that could, at the extreme would be a knowledge graph, right? So, and then somewhere in between would be the things that NLP people would normally do, right? And so your pipeline and the tools that you built are basically designed to do this using LLMs.
Exactly. Broadly, the tasks are a flavor of thematic extraction and analysis. I want to extract some themes from documents and I want to group by these themes and write reports or summaries. So, using LLMs, you can program what it means to be a theme, right? Maybe in customer reviews, themes can be pain points, they can be specific features of the product. The point is that you want some sort of user steering and guidance here for what a theme is. Then you should be able to kind of extract those, group by them, semantically group by them, and then write, summaries or reports, aggregating those insights across the themes.
So one of the tools that you help build is a tool called DocETL. So maybe walk us through that tool, or if there's any more recent tools that you've built, and what's the typical workflow for this tool?
Yeah. DocETL is my dissertation project, what I'm spending most of my time on. And the idea here is to write map reduce pipelines. So people are very familiar with map reduce in the data processing world, where map extracts, one or more insights per document, and then reduce does this group by and aggregation that I mentioned before. When I say doing this in a semantic way or with LLMs, I mean now the map operation is described by an LLM prompt and the LLM executes that. So maybe that prompt is extract all the pain points and any associated quotes with those pain points. So now the LLM outputs a list of pain points and quotes. Then you can kind of imagine flattening that out across all of the documents having some group by on the pain points. And again, this is semantic, right? It's not exact match. LLMs are inconsistent in how they extract and phrase things. But once you group by the distinct pain points, then you can have another LLM do the summary. So we've seen all the quotes for that pain point, and now we want to produce a report that then gets sent to some higher up or some executive, inform some product decision or so forth. So docetl exposes these map, reduce, filter data processing primitives that we're all familiar with, and kind of orchestrates them to scale up when you have lots of data, orchestrates them to scale across task complexity. So what if you want to extract 50 things from a map operation? Turns out you shouldn't ask an LLM to do 50 things at once. You should group them into related things, decompose the task maybe into 10 different subtasks that each do 5 things. So docetl employs some kind of accuracy optimizations to achieve that. So that's kind of one side of what the workflow looks like. The
So
other side of
so
yeah
the user in what you described could be a non-coder, right? So it can be
yeah
an analyst, and it could be not the entire pipeline. And by that I mean, right? So imagine I'm an analyst and I have a bunch of clinical notes from a hospital, right? So, and I just want to extract something and stop there because some of my other fellow analysts might do something with that, right? So I don't need to aggregate. I just want
yeah
to extract, right? So
exactly. It can be any
basically,
pipeline.
I can be a non-coder and I could do parts of the pipeline you described.
Absolutely. And people do that a lot. They will just write maybe a single map operation or a map with a filter because they're only interested in maybe certain types of symptoms if it's in a clinical setting. And then they can give that to whoever is interested in
But
testing.
the end user you have in mind, Shreya, doesn't even know the words map and filter, I imagine.
That's the goal. I think right now we're in a stage where people do need to learn data processing primitives in this way. And it's one of the real struggles that we have. Like how do you onboard people who've had very real analytics needs and unstructured data? For example, doctors, lawyers working with contracts. But it's just a big onboarding to get into WTO. So a lot of interesting, I think, HCI forward questions there.
And obviously, as you mentioned, right? So these LLMs are probabilistic. You can set
Yeah.
temperature 0, temperature 1. And so, do you also set the expectation with the end user that each time you run this pipeline, you may get different results? So, in other words, if you're going to use my tool to generate something for an earnings report for Wall Street,
Yeah.
that might not be the right match.
We observe that there's kind of two different types of tasks. One is where you want the LLM to be accurate. There's like an exact ground truth. So, for example, extraction where entities are very well defined. In that case, you observe people set the temperature of the LLM to 0, so at least gives off the impression that it's deterministic. And they're just going for accuracy, right? What they would train an original ML model to do is now being done in docetl. The other category of tasks where non-determinism is actually very challenging is when you want to offload some kind of creative process to the LLM. So in the most extreme case, tell me what's interesting in the data. People love to submit this query to, docetl like pipelines. And anytime you run it, the LLM might see something different that's interesting. And what ends up happening is that they will run it like 10 times until there's no more new interesting insights that they have gleaned from the data. And I think this speaks to, a different paradigm of working with data. It, Maybe it's the non-determinism gets turned into like a feature and not a bug in the most generous case. But it's really interesting to think about, okay, when is non-determinism an actual problem? How do you engineer systems around it? Like reproducibility is different from accuracy, right? Being non-deterministic is bad for reproducibility, but perhaps it's good in these creative settings, right? So how um, we're running some user studies actually to figure out how to think about this trade-off. So hopefully I'll have more for you.
So do you? I imagine there's also a scenario where you have a data engineering team that
Hmm.
uses this. and then they're responsible for taking the, I don't know, the 2 million PDF files and turning it into something almost like a data warehouse that people can query, right? So in
Yeah.
other words, there's this team that does all of the heavy lifting with docetl, and then the rest of
Yep.
the analysts just benefit from that. So
Totally.
in that particular setting, do you have, I don't know if you're familiar kind of with that lake house architecture where they have this notion of the medallion architecture?
I'm familiar with
You
it.
know,
We
the bronze, silver, gold. So
Yeah,
I wonder if there will be a bronze, silver, gold in this
in
world as
this like a
well.
semantic bronze, semantic silvers. I
Yeah.
think it's interesting. Actually, a few people have meant people actually use docetl to create a table out of PDFs. Like that's it, and then they will put that table. The table is in a relational database, and then can be queried normally. And I think like that's the best way to think about, how do we move forward in the enterprise setting, right? People have unstructured data already in their
Yeah, I
tables.
imagine graphs as well, knowledge
Yeah,
graphs, right?
absolutely. Absolutely. And the other thing that I've seen that's very interesting is people using these tables kind of in RAG or in downstream LLM applications. So I don't know, maybe we're going all circular.
So so let's say I work in an enterprise, I'm listening to this episode. I'm liking what I'm hearing, but on the other hand, I'm also realistic enough to know that this is a fast moving space and that there's a lot of open source libraries that are good, very good at very specific things. And so to what extent is docetl able to leverage other libraries? For example, BAML. I don't know if you're familiar with
I've
BAML.
not heard of BAML. What's BAML?
DML, yeah, 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 it's fantastic. Yeah, yeah,
I'll
yeah.
have to look it up. What does it do?
It turns prompts into functions. It's a domain specific language
Oh, cool. Cool.
that turns prompts into functions. So basically, you never have to agonize over your prompting again. It injects software engineering rigor into the process, right? So, and I imagine there's other things on the information extraction side, right? So
Yes.
I imagine you might not be the best at getting the maximum amount of information out of a PDF
Yep.
file, right? So, like PDF
Totally.
files had images, and what if I want you to interpret the image, right? And so on and so forth. So, there's a lot of libraries just in the Python ecosystem. So, to what extent is docetl kind of
Yeah.
able to leverage the best of breed?
Good question. We do have plugins and operators as plugins that, users can write their own. People have done this before. People have written, so for example, like a clustering operator. Community members have contributed different plugins for data parsing. Although we've seen ever since Gemini, and I think, yeah, Gemini has now the ability to natively process PDFs in LLM call. Now people are switching to Gemini. Also, it's really cheap, so I think there's a lot going for them. But it is pluggable in that way. One of the things that we're thinking about also is having native integrations with RAG. Right now, we don't have retrieval primitives yet. I've been very torn on where retrieval is going to kind of end up for these kinds of pipelines. Just again, as you mentioned, things are moving so fast. But I will say that we're very much, trying to keep up to date with everything as much as possible, and we're trying to make the system as extensible as possible. And it's all open source, so hopefully it's easy to get started.
Right now, if you were to describe docetl, what are some of the most common data types? So I imagine PDF is one, right? So
PDF. Yes. Some people also will run like a OCR, Azure OCR on the PDFs, and then it'll just be unstructured text. Transcripts, JSON formatted logs that you can just like export out of, Sentry or, whatever tool that you want to use. But the nice thing is like so much data can just be represented as a string in any way. And then it's
So
fairly
basically, your
straightforward after
starting
that.
point is string. So I can have like a bunch of MCP servers that
Hmm.
suck data from, I don't know, Confluence, enterprise wikis, I don't
Yeah.
know what else, and then you start from there.
Yes, exactly. Yeah, our data sets are like CSV or JSON format. So you can imagine a CSV with like one or two rows with like big text blobs. It's our one or two columns.
So you handle the pipeline, right? So, but as a user of this tool, do you provide me with any sort of diagnostics or evaluation tools?
Good question. So this brings me to my second part of the stack that we're building, called Doc Wrangler, which is a specialized IDE for writing .etl pipelines. You can kind of see a lot more observability in the interface. It's much easier to engineer prompts. We have automatic prompt writing, the ability to kind of run pipelines incrementally, give feedback on outputs, have LLMs in turn edit prompts. So it really gets you from zero to starting pipeline. And then we find that people export that pipeline and then scale that up to their entire data set afterwards, just with docetl and code. And that paper on Doc Wrangler is coming out, I think, next week. So that's very exciting for me.
In the classic data engineering for data warehouses, people now have evolved to use things like expectations,
Hmm.
assertions.
Yep.
So is there the equivalent in this world?
We have guardrails on LLM powered operations. We have guardrails for example, like you can have them code based, just making sure, the output is indeed mentioned in the input document. You want to check for hallucination. Then we also have you can repurpose LLMs to be used as guardrails or LLM as judge pretty easily. We have the ability to automatically loop on an operation if an LLM as judge prompt does not pass. And you could imagine creating a pipeline with additional LLM operators that query some external data source or do some sort of validation, return a true or false, and then you can filter after that. You can drop documents that don't meet criteria. And this is a common pattern that I see also in Doc Wranglers, people just adding operations to kind of do LLM as validators, improve reliability in that sense. And I think there's a separate thing that we're discovering around how to do this in teams. How can we align multiple stakeholders on what means for good outputs? How do you kind of go through multiple rounds of grading outputs and figuring out whether your intent is aligned with the LLM? But that's, still stuff that we're observing very early days of that.
So everything you just said just kind of raised uh, in my mind, especially if the goal here is eventually to onboard non-coders and analysts,
Yep,
that a lot of this work is actually going to be innovation is going to be on the UX side,
absolutely.
right? So what do you have folks thinking about this, or are you starting to think about this yourself?
Yeah, the Doc Wrangler project is all about, what's the right UX for people to build these semantic data processing pipelines? How do we scaffold people through initializing them, through inspecting them, and improving them? And how can we, leverage AI assistance as much as possible in this process? If you think about the whole semantic data processing ecosystem, it's super new. We're building tools for this. But there's three entities that you need that make this really hard. Right? There's the user. User has an intent that is hard to express perfectly. There's the semantic pipeline, the LLMs, right? The LLM might not understand the user, or the LLM also might have a completely different definition, even if many users align on the same thing. It's all about how the LLM was trained. And then there's the actual data, right? There's the documents or whatever data that you're trying to execute the pipeline on. We know that LLMs fail in like these weird ways. For example, if you have really long documents, the same prompt might not do very well. Like if you want to extract all entities from a 100-page document, that might not work. But if you do it for a half a page document, it works perfectly. This gap is like super weird in between the data and the LLM that we're still trying to build systems to solve. But when you think about building UX and interfaces for semantic data processing, you have to optimize the interaction between user, semantic pipeline, and data. All three of those. So that's kind of how we're thinking about this moving forward. Where does AI help? Where does AI not help? How do we get users to very simply provide feedback along the way, steer it as much as possible? But lots of very fun research problems. I think that's so important to stress. It's like day zero of this whole field. And I expect this to, only grow, right? Organization of so much unstructured data. There's so many people who don't know how to code. How can we make these systems more robust and more approachable. I think it's very exciting.
You should definitely check out BAML.
Yeah, I will after this, right after this.
Um, yeah, yeah. So of course, uh, everything that we've discussed is in the context of a very fast moving foundation model world, right? So now we have reasoning models, and I don't know how you feel about the reasoning models in the context of what you're doing, because obviously, right? So the reasoning models might be better, but one, they're computationally expensive, they're slower, and then they might cost you more. So what advice do you give people who use stock ETL? So when should I use a reasoning enhanced model, and when should I hold back, or should I just fine tune the hell out of a small open weights model and then forego reasoning altogether?
Yeah, it's a good question. I think we're still in the AI world in the early days of knowing what kinds of tasks reasoning is helpful for. But I can give you my data processing perspective. I think reasoning is most helpful in bridging the understanding gap between the user and the initial pipeline that they write. Like if a user has documents and they can kind of crudely say what they're interested in extracting or analyzing, a reasoning model can really help go from um, that crudely specified intent to maybe a well specified pipeline or like a .etl pipeline. We have a functionality in Doc Wrangler that is like natural language to pipeline, and we find that the O1 model is like much better at doing this than GPT-4o, 4o many. But at the individual operator level, for example, like the actual extraction that you want to have, if you already have some examples in the prompt, if you already have a pretty well defined prompt, the reasoning model doesn't give you extra leverage there. So it's less about the latency and more about the fact that, the non reasoning model can actually do that task around extraction, around summarization. They've been trained to do that from the beginning. Like, unless you're trying to, like, solve math problems in your data set, I typically don't see people having to use I don't think I've ever seen a case where people need to use, like, the O1 like model. One case where, somebody said that they are using a O1 like model is, when they've, like, uploaded their data set is a collection of several, educational PDFs, and they wanted the LLM to kind of create flashcards for them. Like this was like medical education or something. I don't know. Um, and liked, the ability to reason throughout what was like a good question. But I don't know how much, that specific use case is representative of both semantic data processing tasks.
I would imagine in most enterprises, supervised fine tuning will pay off for
Yeah,
a pipeline, right?
absolutely.
So you would think that that would be step number one. If you kind of know what your pipeline needs to do, then you would do supervised fine tuning. And so I guess the question is, what's the rule of thumb for for the number of examples?
Yeah, that's a good question. Unfortunately, I think when you run a dog-ETL pipeline that will give you labeled data, then go train your models and then replugs the models or redirect it to your trained model or not. But I haven't seen people, no one has told me explicitly that they're doing this. I'm sure people are. I know people are um, writing dog-ETL pipelines on their own LLMs, but I'm not sure how they fine-tune those or if they did that prior to using DarkETL or after.
By the way, I might be an anomaly, but when I use these LLMs for pipelines, I never use one LLM. I always use two or three, and then
Exactly.
and then I try to get a consensus. Because
Yeah.
basically, I think they all have their strengths and weaknesses, frankly, right? So, I mean, obviously, my starting point will be your guys' leaderboard LMSys, just to
Mhm.
get a feel
Yeah.
for what I should be trying. But I would never say, okay, since LMSys says this is the best, I just accept that as gospel truth. No, it really it depends on your use case and your data, right?
Totally, totally. All in all of our user studies, people say the same thing. And if you look at we have a pilot deployment that we did. We collected a bunch of telemetry for the paper that we're releasing next week. Um, the standard pipeline is like try to use OpenAI or Gemini models for extraction. And then for any report generation or summarization or like content generation, so think like reduce operations, it's Claude models. Almost like all the time, you can just see that. Um, I think
So
that's
no,
interesting. I don't know. I
so
wouldn't have
no
expected that.
no deep seek, huh?
There are some deep seeks. We ran most of this pilot before DeepSeek became really, really popular this year. But I should check. I'm sure DeepSeek has risen in popularity.
By the way, I think you boxed yourself in with the name of the project Doc ETL because now we're seeing multimodal foundation models.
Yeah.
So it's no longer just doc. Could
Hmm.
be audio, video,
Totally.
images. So I'm assuming that because the premise of what you're doing is based on foundation models. As foundation models become more capable, you just move with the capability of the foundation models, right? And so we need to come up with a different name for the project then.
Yeah. It's so interesting. A lot of people have, when we first released the project, a bunch of people were like, oh, you should do multimodal. You should do images. You should do audio. And and then a lot of those queries just kind of vanished. Like, more people were just like, "Yeah, I just have text problems, and I'm gonna use this for text." So I think, like, we're just in the gritty stages of, like, the real actual business use cases that people have are text wrangling problems. And totally, images and videos and everything audios, we should definitely incorporate that into the system, but you can certainly, like, get so far with just trying to figure out how to solve text data correctly.
Yeah, yeah.
That's
Because
what I'm
I think
learning.
on because the default is to use text because basically you have a podcast, you get the transcript. You have a video, you get the transcript. But the reality is there's a lot of nuance
Yeah,
in these other modalities, right? Especially video, right? So, because there's a lot of nonverbal nuance. So, I would be
totally.
remiss if I don't ask you about related projects. So, Data Prep Kit, Aaron.
Yeah,
So,
yeah.
what's the relationship with these projects?
I just met the errand people a couple months ago at a conference. I think there are a bunch of people building systems in this space. That's what makes it very exciting.
I think Aaron, as I understand it, is you take your unstructured text and then the output is some sort of hierarchical data structure.
Yeah, I don't know where exactly that they pivoted to, but I think all of us, share the interest of doing semantic data processing. There's pretty much like many institutions now, like have a group of people building such a system, and hopefully we're all meeting up soon, like in a month or so, just to share, research progress and so forth. But it's been interesting to see where we kind of differ intellectually. For example, at the operator level, some groups, some systems are like, so Jock ETL, for example, has a single kind of unified map operator, which is one-to-one document to output. But some other systems will have like 20 different types of map operators, like extraction type map operators, summarization type map operator, like the type of task you might want the LLM to do, even though it's just one-to-one. So there's a lot of these like interesting, implementation differences that I think we just don't know the answer to. How are people going to use a system? What's the easiest to learn? And I think what makes it also very difficult is because as the ecosystem is changing, as you said, like people wanting to use Claude to write docetl pipelines, and then now all of a sudden we're like engineering the system for Claude and not for the end user.
Correct.
Um, Kind of just either stabilizing in any sort. It's hard to tell like how systems are different, how they will be different in the future.
So, I guess let's close with scale. You're in Berkeley. Tell me you're using Ray.
Everything actually runs on a single machine right now,
Okay.
but we will scale up with Ray. I gave a talk, I think this is Cloud Era, and the first question was like, "Can we scale this up to like hundreds of machines?" I was like, "The LLM bill when you're running semantic data processing pipelines on hundreds of machines makes me anxious." But once they get cheaper, yeah, totally, we'll scale it up with Ray.
Or maybe they have on-prem DeepSeek, right? So,
Yeah, maybe in that case.
yeah, yeah.
Yeah, but these albums are not cheap. They're getting cheaper, like 10x cheaper a year almost, which was great.
Tell me about it. I just looked at my OpenAI bill. I'm going, oh man, I'm gonna switch away from these guys.
Yeah, Gemini is really cheap. for
Oh,
data
yeah, yeah,
processing.
yeah. I mean, Gemini is almost basically free,
It's very incredible.
and then it's actually better in a lot of ways. And with that, thank you, Shreya.